debugging is a very associative process. If things get very, very, very messy, you can start doing a more standardized process. But early on in the process, I found that associative thinking leads to faster results in most of the cases. And that's another reason to look at the code, because once you kind of get a look of the code, get a sense of the lay of the land, then you're better positioned to look at additional data, whether it's logs or metrics you've discussed or the bug report itself or anything else, to kind of see things in context rather than just trying to piece everything together from scratch.
What's up, friends? This episode is brought to you by SourceGraph. With the release of SourceGraph 4.0 and the Starship event just a few weeks behind us, it is super clear that SourceGraph is becoming not just code search, but a full-on code intelligence platform. And I'm here with Joel Kortler, product manager of Code Insights for SourceGraph. Joel, this move from code search to code intelligence is a really big deal. How would you explain this feature, Code Insights, if you're just talking to folks in the hallway track of your favorite conference?
I would really start with the technical, because before I was product manager, I used to be an engineer as well. And it's really cool and exciting just to be able to say, we're going to turn your code base into a database. And the structured language that you need to interact is just the ability to write a code search. Literal search, that's totally fine. Regular expression, that'll give you a few more advanced options, even a structural search. But the number of long tail possibilities it unlocks, truly the journey of building this product was just saying, well, we've just unlocked, an infinite number of possibilities. We got to figure out some immediate use cases so we can start to, invest in this product, build it and sell it. But we're only getting started in terms of the number of uses that we're uncovering for it. The story I told you about discovering version tracking turned out to be a really important use case that wasn't even on our roadmap 6 months prior to discovering that, as we were already planning to launch this product, until we talked to enough folks, realized this was a problem, and then found, that's a simple regular expression capture group that you can just plug right in, because we really built this system to not limit the power of what we built. We don't want to give you 3 out of the box templates and you can only change 1 character or something. It's truly the templates are there to hold your hand and get you started, but if you can come up with anything you want to track in your code base, you can do that with Code Insights.
I love it. Thank you, Joel. So right now, there is a treasure trove of insights just waiting for you, living inside your code base. Your code base is now a queryable database thanks to SourceGraph. This opens up a world of possibilities for your code and the intelligence you can gain from it. A good next step is to go to about.sourcegraph.com/code-insights. The link will be in the show notes. See how the teams are using this awesome feature. Again, about.sourcegraph.com/code-insights. Again, this link is in the show notes.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from all around the Go community. We record live each and every Tuesday at 3 p.m. U.S. Eastern. Subscribe at youtube.com/changelog to be notified, and join the Go Time FM channel of Go for Slack to chat along with us. Special thanks to our partners at Fastly for delivering Go Time super fast all around the world, and to Fly.io. Deploy your app servers close to your users. Learn more at Fly.io. Okay, here we go.
So today we are talking about Debugging Go, and I have to share that this is actually a re-recording of the episode, because as much as we did our best to have redundancy and double local recording and saving and whatnot, the internet was bad, the audio was bad, everything was bad, so we are re-recording, and we hope that this time there will be no black boxes for us to poke. I am joined by my co-host Ian. Hey Ian, how are you doing?
I'm doing well. This one's going to be interesting for me because I'm definitely still one of those print people. So we'll see if I learn anything.
We're also joined by Liran Haimovitch and by Tiago Queiroz. And gentlemen, would you like to introduce yourself? Liran, you are joining us from 1 hour in the future. You're joining us 1 hour away from Berlin. You are in Tel Aviv.
Yeah, so I can definitely relate. Print has its privileges because debuggers can be so cumbersome and often hard to use in so many cases, and so much easier to just say, I want to know what's happening on this line. Let me add a line recompile, rebuild, ship it, and get to know whatever is happening there. However, rebuilding the software and shipping it isn't always that easy, which is kind of where Rookout come in. So my name is Liran Haimovitch. I'm the CTO of Rookout. Spent about a decade doing cybersecurity. And now for the past, 6 years now, I've been focusing mostly on observability and how to use dynamic instrumentations and other concepts from cybersecurity to make observability, debugging more agile and easier to use in production environments.
Thank you for joining us. Tiago, you are also here in Berlin.
Yes. Hi, everybody. I'm Tiago. I live here in Berlin. I'm originally Brazilian. So I'm a software engineer. I've been working mainly, almost exclusively with Go for more than 5 years now. Currently, I work for Elastic on the Elastic Agent and Beats. So it's interesting because lots of our debugging there is basically logs, because we basically build binary ship, people run it. They sometimes run into issues because, no software is perfect. So actually log statements and print debugs is still one of the main ways to discover what's happening, especially when the issues are not on our machines. And most of my work experience before Elastic was with startups and microservices. Also worked a lot in the sense of bringing observability into some places, and was always advocating for better observability and debugging tools. So that's a topic that I enjoy a lot and try to always bring more, awareness on my workplaces. I need to make things observable and easier to understand when they break. So they should almost tell us, hey, I broke because of that.
The AI will be telling you, you broke it because of that.
Yeah.
So let's talk about some practices that we have today without the AI. What are some good and bad practices in debugging that are maybe specific to Go?
I think definitely the good practice, it's always have logs on your application. Make sure you write your application and you have proper log statements, which it's a very broad concept, what is proper enough, right? And something that you basically learn by seeing other applications, but definitely you should have enough logs for things, especially for if you write a web server, right? Ideally, as soon as the HTTP server is running, it should say, hey, I'm running on this port, on this host. Should show you some information of how it's starting, what it's doing, printing some configuration that might change for environments and might be very critical to solve some issues. So I think the best example, sometimes you run something on staging on a port and then on production another one, but then if you don't set the configuration right, things just don't work. And then if you don't have any log statement, anything telling, hey, I'm actually starting my web server on port 3000, not 8000, you might spend a few hours debugging. So definitely really think when the application is running or starting, what an engineer or even a user, right, that's using your application might need to know if something goes wrong, or just to know about the current state of the application.
So the tricky thing about debugging any language, I would say, is that you're probably debugging the unpredictable, because if something is predictably broken, then you're probably going to have a logline somewhere saying, the system is essentially saying, I'm broke, this is why, just go ahead and fix it. And maybe the system is writing it out very clearly, or maybe you're just knowledgeable enough in the domain, in the application, whatever, to just get a sense of what's going on and quickly pick up the breadcrumbs and know what is what. If you are bothering to debug something, then it's unpredictable to you in some way. Maybe because the bug is super complex, maybe because there's many dependencies, maybe because you're not that much of an expert in Go or in the application itself, and that's perfectly fine. Nobody's perfect, and we all have our knowledge gaps. But whatever it is, you kind of have to keep in mind that if something is challenging, it's unpredictable in some ways, and you have to think about how do you address that unpredictability, whether it's about by pushing those print statements to kind of get a better sense, whether it's about using a debugger or live debugger, or looking at other observability data. Whatever it is, you kind of have to address the unpredictability to get a sense of what is known and build from that. And kind of speaking of Go in particular, one thing I found that often confounds people is that Go is not supposed to have exceptions, and yet it somehow kind of does. Now, I'm not trying to argue with anyone about anything, but panics and defers act very similar to exception throwing and catching them. And if you are new to Go, or maybe you're not very familiar with the code base, panics are often overlooked. Some libraries actually even use intentionally panics as a form of exceptions to unwind the stacks if the stack is very deep. But either way, if you're looking at an error flow, if you're looking at unpredictable outcome, it's always good to think about, is there any chance something is panicking here? And if it is, how can I test it, or how can I make sure nothing is panicking? Because you'll often find that whether intentionally or unintentionally, there could be panics in there somewhere that's throwing your code into some unpredictable flow that's causing you a headache.
So what would you say is the difference between debugging locally versus debugging in the cloud?
I think the main difference is debugging locally. You can run the bug in slow motion. So actually I was at GopherCon in a workshop from Bill Kennedy, and he had told this quote that was very interesting. Like, the function of the debugger is to run your bug in slow motion. So basically that's the only thing it does.
Yeah.
Right? But
nice quote.
It's actually very interesting. And in the end of the day, that's it, right? When you attach a debugger to an application that usually you only do it locally, you can literally run the code in slow motion, stop and introspect things, right? I find it extremely useful to have debuggers when you do not fully understand the workflow of the program, or like the code paths, or there are too many dynamic things happening. If I really understand the program, usually I just always go for print statements.
Yeah.
Because then, like, okay, I passed it through here, or that's the value of that variable. Usually I have a hint what's happening, right? When I have no clue, usually the debug, okay, I know that it's probably gets into this function. And I think that's one of the main difference from the cloud. You can actually attach a debugger. You can run things in slow motion, right? Because if you're in the cloud, even like it's a Kubernetes deployment on your staging environment or something, usually there are some proxies, some things in front of your application that might have some timeout and things like that. And once you put a debugger and say like, hey, stop my HTTP request for, 5 minutes while I think, or maybe 30 seconds, then timeout. You step, especially in Go, you go to some point and then, hey, context deadline cancel the request of this, the context of this request, time it out. So I think that's I would say the main difference.
Yeah. So debugging in the cloud sucks. It really sucks because the two techniques we're used to working with for debugging just don't work as well. 99% of the times you can't attach a debugger. When you're running in the cloud, you can't attach a traditional debugger, whether it's because you don't have the access for it, whether because the debugger itself is going to be holding the process, as Tiago mentioned, but that's going to kill any health probes the process is getting and remove you from any load balancer. It's going to get AWS or Kubernetes or whoever is orchestrating the application to terminate your process and then spawn a new one without your debugger attached. And there are other slew of technical problems, but 99% of the time you're not going to be able to attach that debugger to have the beauty of watching your code move in slow motion so that you can actually spot the bug as it's moving at lightning speed through your code. And also logs, which are nice. They're definitely better than debuggers, which you can't use at all. But again, when you go to the realm of unpredictability, logs are more often than not, I wouldn't say enough or not enough, because that's a harsh statement, but they can be challenging to read. They can be challenging to sift through and grasp the bigger picture and find essentially the needle in the haystack. And it's not just about how many logs you have, it's also about where are they positioned compared to the bug, and how much information do they actually reveal about the inner workings of the software. And now what, as Ian literally started the call with, is about I like to add prints to gain a better sense of things. And adding prints when your code is running in the cloud, that takes a while. You have to add a code, then you have to either build it locally or push it through the remote. And then that has to build, goes to CI/CD, deploy somehow. It can easily take you 20 minutes if it's a personal environment to add that log line, or it can take you hours or days if it's a shared environment or even a production environment. So you can still debug with prints, but changing them becomes very, very painful and slow, which is part of the reason that the new form of debuggers, the live debuggers, have kind of spun up, which are super useful. And we actually released Go support last year. And I think that's something that makes cloud debugging so much easier when you can get that traditional sense of setting breakpoints and seeing the data while still working with load balancers and API gateways and Kubernetes and all that magic.
Yeah, I want to hear more about that cloud debugging. Like, I've not heard of that. It's kind of blowing my mind. Can you just elaborate a little bit?
Sure. So at Rookout, what we aim to do is provide you with developer observability in general, but first and foremost, a debugger-like experience without any debugger involved, essentially. What we ask you to do is install our agent or SDKs. For Go, it's just a Go package, a Go module. And that Go module essentially connects to an orchestration service we run. And then we kind of provide you with what would happen if I placed a breakpoint here. So you go into our platform, you place a breakpoint or a non-breaking breakpoint on that line of code. And the next time this line is executed, it can be once, it can be 100 times, it can be more, we collect snapshots. And those snapshots looks exactly like a breakpoint would show, what a debugger would show if a breakpoint was hit. So you would get a stack trace, you would get the local variable values, everything, except those snapshots are asynchronous. So the application doesn't stop, it doesn't wait for you to read through the slow motion of debugging. We slow the application for a millisecond or two while we capture that snapshot, and then you can read it, take a look at it offline at your leisure. You can go back and forth between different snapshots, so you can see how the code is running, supposedly in slow motion, except the code ran really fast as it was executing.
This episode is brought to you by Honeycomb. Find your most perplexing application issues. Honeycomb is a fast analysis tool that reveals the truth about every aspect of your application in production. Find out how users experience your code in complex and unpredictable environments. Find patterns and outliers across billions of rows of data and definitively solve your problems. And we use Honeycomb here at Changelog. That's why we welcome the opportunity to add them as one of our infrastructure partners. In particular, we use Honeycomb to track down CDN issues recently, which we talked about at length on the Kaizen edition of the Ship It podcast. So check that out. Here's the thing. Teams who don't use Honeycomb are forced to find the needle in the haystack. They scroll through endless dashboards playing whack-a-mole. They deal with alert floods, try to guess which one matters, and they go from tool to tool to tool playing sleuth, trying to figure out how all the puzzle pieces fit together. It's this context switching and tool sprawl that are slowly killing teams' effectiveness and ultimately hindering their business. With Honeycomb, you get a fast, unified, and clear understanding of the one thing driving your business: production. With Honeycomb, you guess less and you know more. Join the swarm and try Honeycomb free today at honeycomb.io/changelog. Again, honeycomb.io/changelog.
So you mentioned that you can do this cloud debugging with snapshots of how things are when you place those breakpoints as a way of doing that in the cloud that is quite easy or easier. Mm-hmm. What some good practices that you have to make debugging easier? So what can you do to help yourself, your future self, your colleagues when you do debugging generally? What are those practices that you're following?
So obviously logging. As Tiago mentioned, logs are awesome. You shouldn't skimp on logging. You should also keep in mind that there is such a thing as too much logs, especially when you get your bill from your log aggregator. So do watch out for that. But that's an entire topic about optimizing the cost and volume of logs. I'm not going to dive into that. From my experience, most people err on the side of too few logs, especially early on. The other thing which kind of touches back to a point I've mentioned is when you're writing code, focus on the error conditions. I think I read somewhere that when you write code, about 20% of your code deals with the happy flow, deals with what should happen, and then 80% of your code deals with what shouldn't happen. With validating inputs, with responding to errors, with network disconnections, with database errors, with God knows what. And that's where 80% of your code is going to lie. And complexity-wise, way more than 80% of your code is going to be there. And try to focus as much as you can on thinking through those errors as you're writing the code. While it's definitely useful to write a log line saying you've entered a function, maybe it's an important function, maybe it's going to be useful someday, that log line is far more likely to be noise and far more likely to end up in the bin of those logs are costing me way too much money and it's time to turn them off. On the other hand, adding logs for error states, those are way more useful. Something went wrong, make sure you write a log line about it. I think one of our first customers at Rookout actually used Rookout, at the time it was Node, a Node application to debug a bug they've been chasing for over 6 months. It was a super complex bugs, and they were doing OAuth 3-sided authentications, and they got a cookie, and it actually had this error validation code that assumed that if the cookie was too big, they were going to truncate it. Now the cookie held a JWT token. Obviously, it's a signed artifact. If you truncate a signed artifact, the signature is not going to be valid, sending you down all through kinds of pain. And they literally had a comment on that if statement, add a logline here. Add a to-do comment to add a logline. It literally said, this should never happen. Add a logline. And they didn't add a logline. And they've spent over 6 months trying to figure out what was going wrong and why some users couldn't log into the system. And that was because their cookies were too large because of various settings somewhere else across the world.
Yeah, definitely watching out for your error logs. I think that's like one of the most helpful things, but not just the logs themselves, but like craft good error message. Don't just say, hey, I broke, or like, I don't know, error inserting on the database. Try to give a context of why that thing failed. Fail inserting, like for simple thing, like for example, it's an insert, at least print the name of the table. Maybe you cannot print the whole SQL statement, but you can print the table, or maybe say failure inserting a user or doing something. So like try to explain it, giving context why you in that error path, right? Like Liran said, watch out for those error handling code. That's usually where lots of bugs and issues are going to happen. Errors are not well handled, or even worse, like they're handled, but like they're just hidden. And then you, when you run the application on your logs and things like that, you don't see that there was an error. Or maybe the application exits from like a error handling path, but it doesn't tell you why. Or there's an error, but doesn't tell you why. For example, I actually have a good example. Like recently, we had some PRs on our applications, like adding more logs, adding more context to this error log, because it's something like, oh, I cannot start because the log file already exists, right? So maybe there's another instance, but it didn't tell where the log file is located. It just says the log file. It's there, but like, okay, where is the file? How do I find it? To find which process is holding that file. And then maybe if you go to lots and lots of logs at the very beginning of the application, it says, oh, my configuration path here. And then you have to know that you need to join that with something else to find the log file, right? But why not just print together? Like, hey, the log file, here's the whole full path. Already exists. I cannot start. So sometimes simple things like that can make a whole difference. So maybe found a recoverable error, have to shut down, but here's the error, here's the situation. Like try to show the code path that led to the error, to error handling, and give as much context on your error message as possible. So someone reading the log or even reading the error in whatever observability tool you have, the person reading it can better understand why that happened.
So we've talked a lot about logging, and it sounds like for errors, logging is the way to go. Where do you think the place of like stats are, like counts and histograms of latencies, and Where does that sit in the debugging landscape?
That's a tricky question. Metrics are, they are one of the most complex and powerful ways to monitor software. You can get a lot done, especially if you're looking at large-scale systems, production systems, those sort of things. But you also need to have some basic understanding of how metrics works and how to approach them. You also need some real-world experience with your specific application, because numbers that can be awesome for one application can be terrible for another. And some of this lies in the business context, in the domain you're operating in, and some of it just lies with the characteristics of your applications and various decisions you've made along the way. Obviously, there are a few great places to start that are always good. Looking at your requests per second, looking at essentially how many requests your application is processing per second, looking at your latency, how long does it take you to process a request, looking at your error rates, how many requests are successful versus how many are not. But then there are all sorts of fancy ways to look at the data which change. Do I look at the median, the average, the P90, the P95, the P99? Depends on the context. Some applications might make perfect sense to look at P95, while others might have to look at P99.9, while others still might look at the average. Also, what dimensions do you look at those metrics? How do you break them down? Do you have multiple regions? Do you want to monitor it per regions? Do you have multiple endpoints? Do you want to monitor it per endpoint? Do different endpoints have different tolerance for latency or for errors? And the list goes on and on and on. So on the one hand, if you're looking to monitor an application in production, getting some metrics in there is a great start. But it's also a dual learning curve, both on learning how to use metrics in general, but also about learning what's normal and what's good versus what's bad for your specific application.
Yeah, like I think metrics are not, I wouldn't call them like exactly a debugging tool. They're more like to understand, because metrics are aggregations, right? Usually you get like average requests per second, average thing, like given a number of requests of instructions of executions in a given time. Those are like metrics of like usually for request latency, throughput, maybe database connections. So usually you cannot pinpoint like one thing or get one transaction and then get the metric and use those aggregations. But they also help you to maybe understand another thing, like which bugs are actually like, let's say, worth fighting right now, right? So if you have metrics like error rates, right? And you have like 50% of your requests are always failing. So definitely you have a big issue there, right? Lots of people are being affected by this bug. But if 0.1% of your requests are failing or are too slow, and that's basically meaningless in the number of users, maybe there are actually other bigger bugs to know that's going to have a better impact for your users to solve. So definitely, I think metrics can help to prioritize, and definitely performance issues, right? So if you want to improve performance or you actually have performance issues, then those metrics will be there. Even though you can handle performance issues as bugs, when someone talks to me, oh, there's a bug, let's debug something, usually I think more like a code level, a weird behavior of the one specific application, rather than, let's say, every time I have too many requests, the database dies, right? Usually I don't think that is a bug. It could be a bug in the code that you're making too many requests to the database or no optimized SQL queries, could be, but at least that's how my mind works when I hear the word bug or debugging.
We talked about good and bad practices of debugging. We talked about debugging in the cloud versus on-premise. We talked about stats versus errors or logs. Let's talk about debugging in production versus not. Are you debugging in production? If yes, how?
Yeah, I think in the case of like working with Elastic, it's a very interesting case of debugging production because, well, we don't have access to the user's environment, right? So basically, we only rely on logs and asking people, hey, what have you done? So that's where you actually see two things: the power of actually having good logs, and also you see the other side. Logs can be too verbose as well. Like you have some applications, if you enable log debugging and it has a very high throughput, then sometimes you get like 100 megabytes of logs and it's like 3 seconds of execution because it's just too verbose for some stuff. So yeah, I think that definitely debugging production has this facet of sometimes you actually don't have access to environment, and say more often than not, you mostly rely on logs and metrics, and that's all you have. So you basically, let's say, looking to the past. Okay, something happened, like I have things that point me what happened in the past, not right now. That's different from debugging, or even locally, or even usually on staging that you have more control of the environment.
And you can't really reproduce what the person who reported this has, because it's not like, send me your code and I'll try to run this, see how that works.
Yeah, sometimes you just can't, or sometimes you do your best to get as close as possible. But yeah, that's the thing that reminds me something. Yeah, sometimes you can't have access to production or to the actual environment, but you can reproduce a close enough experiment if you have enough information. Okay, every time those situation happens, then there's a bug. Then you go to your development or staging environment and you reproduce as close as possible. And then you can actually debug, run your debugger, run your tools.
One of the fun things about being the CTO of Rookout is I not only get to see how our engineers debug in production, but I get to work with many of our customers who are debugging in production. And many of our customers have, I wouldn't say given up, but come to realize that they need a better solution than the traditional approach for debugging. Monitoring tools were not meant for debugging. Monitoring tools are meant to show you something is wrong. Your application is down, you're having some issues with some of your endpoints, some of your users are not getting the best service, but they were never designed to pinpoint exactly what's going wrong. And especially many of those issues are code-related issues today with cloud native applications, when you're essentially moving away so much of the infrastructure to somebody else, your AWS or Google Cloud or Azure or whoever you're picking, I don't know. Most of your bugs, most of your issues are somewhere in the code, and you need a lot of granularity. And many of our customers have figured out that whether they try to make their engineers more productive or solve customer issues faster, or both, they prefer to be able to truly debug in production. And we see a few considerations and hurdles in how you approach that. I mean, security is a big thing. You have to make sure that whatever tool you're using, you know who can access the system, you know how it is being accessed, that everything is secured. There are a lot of privacy regulations across the world in general, in Europe in particular. So you have to think through that. You have to know that what private data is being collected, is it being removed through the process, is it being stored, who is storing it. And obviously you have to think about performance and availability. Will the access and the tools I provide my engineers somehow impact the stability of my application? Will it impact the performance of my applications? And whenever you're thinking about debugging in production, and it doesn't matter if you're giving them some fancy tools such as Rookout or providing them with SSH access to go do their thing, you need to think about the implications in those elements, and especially how the non-functional requirements of your system, which can vary greatly between domains, between companies, even between applications within the same company. You have to think about that and how you address them. But other than that, than the extra risks and significant extra risk involved, you still go back to the same fundamentals of debugging we've discussed through this call. And once in a full moon, I actually meet somebody who decides to attach traditional debugger to production because either the issue is bad enough that they have no choice and that's all they have to do, or because for some peculiar reason it doesn't disrupt their system all that bad for some reason and they can afford to. But at the end of the day, you end up with the same techniques, just a different risk aversion scale.
So I want to go back to logging just a little bit. I know we've talked about it a ton, but we mentioned earlier that sometimes there's not enough logs, sometimes there's way too many. Do you think log levels play a role in that? Is there something that we should use? In the Go community, there's a lot of kind of argument that just a single log is enough, and other people like the levels. What are y'all's thoughts?
Yeah, I would say it depends. I've gravitated towards different opinions of like you should only have one level or you should have multiple ones. And I think it definitely depends like what kind of applications you are developing, right? If you like deploy your own microservices on your infrastructure, then you have way more control. So maybe you can get away with like less log levels and really craft good log messages. But if you actually deploy like providing binaries that people are going to download and run, then at least at the debug level would help, because then you can say, okay, those are things that most of people don't need. It's just going to waste disk space and things like that, or like log storage if they're shipping there somewhere. So 99% of the time, we're never going to need it. But then when there's an issue, then we actually need to see that. And in some of the applications that we have at Elastic, we actually have even a different approach. We do have the log levels, but also we can filter specific loggers. So different parts of the application, they still set the logger like, hey, I'm a harvester, I'm an input. So you can say, I want log the bugs from our inputs or from our parsers or from something like that, or from the output. It's almost like setting different log levels for different components of the application. So that's also an approach that I find quite interesting. It can be quite useful, especially when you have this situation of like logs are probably going to be too verbose, some of them, but then you can filter out the verbose ones, not like even generate them. And then you focus on the things you actually need.
So log levels are super important. You can't do without them, at least if your system is any scale, especially when it comes to how much traffic it's handling, because you're going to have to cut logs somehow. And verbosity levels is the easiest way to get started with. Obviously, you can get fancy later on, as Tiago has mentioned. But when thinking of log levels, there is one thing you have to keep in mind. When you're looking at most SaaS operations today, when the same team both builds and operates the software, log levels, especially in the long terms, tend to be gamed. Now, take an example. Let's say you're running the application for the first time. You're probably spewing debug logs. You have zero traffic. You're printing everything. You're just dying for somebody to bother to go to your website or whatnot. So why not just print everything? Then later on, the application grows. You get more traffic. You move to info. Still no biggie. But then at some point, your application explodes. You have tons of users. You're paying way too much traffic, way too much money for some log aggregator somewhere. And all of a sudden, some ops guy come and say, or girl for that matter, comes and say, let's cut back. We need to move to warning level verbosity and above because we're just wasting so much money and nobody's looking at those logs anyway. Now, you might have a pretty well-defined verbosity levels. You might not have those well-defined verbosity levels. But the next time some software engineer is going to need some piece of log to troubleshoot something or get their job done, I can assure you the level of logs they're going to use is going to be warning and not info or debug, regardless of how important that log is, because it's people. They game the system. If they need the log line, then they're going to do whatever it takes to add that log line and get their job done. Now, in the long term, that means that every time you increase the minimum verbosity of the log levels, you're going to be dropping some logs, but new logs are going to be added, and a lot of the other logs are going to get moved, refactored into the newer level. And that's not necessarily based on importance. It's based on what was most recently used by your engineers, which doesn't necessarily provide a good feedback on what's truly important. Not to mention that some engineers might be more straight shooters than others, in which case things can get even worse because some engineers are going to game the systems and others won't. Long story short, log levels are not going to fix everything for you, but they can definitely help to a certain degree.
I love that point about gaming the system because I have definitely done that. without a doubt.
We're recording this,
Oh yeah, we'll make this error because I need to see it.
Yeah.
Oh, I'll admit it all day. It's all good.
I totally agree with that as well. I think, there's some logs that I'm like, no, that's info, because if something goes wrong, I need to know that happened, so I won't put that as the bug. I know some people would call it the bug. I'm calling it info because I want this log line there no matter what. And I know you're running log info, right? That's the thing. I know you're running level info, so I'm putting the level that we're running. Yeah, so I probably am guilty as well of the same thing. But I think, that's definitely a thing. And I think it circles back to the thing. You really need to be careful, especially as you scale. I think like Lian had a great point there. As you scale more and more and more, then the amount of logs become more of a thing. And then that's when you need to really think about what are you logging and how are you logging. So to make sure you always have the logs you need, because logs are the kind of things you usually never look at them unless you have an issue. And then if you have an issue and then you don't have the logs, then you're basically going to make a PR to put the log, to deploy. 20 minutes, if you're very lucky, it might take a few weeks if you provide an application for people to download and install. And yeah, so definitely need to be very, very careful with the logs you write, not to fall on those pitfalls.
Last question, and then we jump to the fun part of the unpopular opinion. When you have to debug something, how do you start?
So I always start by trying to reproduce as close as possible the situation where the bug happened, right? So you usually get, okay, that thing is failing on, I try to reproduce it. It depends a lot on the situation, but I try to make the bug happen on my machine. If the logs that I have are not right enough to make me understand what's happening, sometimes it is. And then job's done, just, okay, here, your error message, that's your issue. Usually that's not that simple. So usually it's set up, let's say a small experiment, so I can reproduce the bug as like in a very easy way. So I can run it over and over until I understand what is causing it. And then there is where I would say the art of debugging starts. Once you can reproduce it, then, okay, why it's happening, right? Then you go print statements, log statements, debugger, changing your environment, changing the state of the application to understand why it's actually the thing is happening.
I think what I most often do is look at the code, especially if I have a descriptive bug report that kind of points me in the right direction. Quite often, if you look at the code with a fresh set of eyes, whether it's your code or somebody else's code, assuming you have a good familiarity with the application as a whole, and you're looking at the suspected piece of code where a bug might reside with a new fresh of eyes and with some description of what's going wrong, you'll often see the bug. It can be enough by one bug, it can be a comparison that's looking at the wrong attribute, which I just had that bug a couple of days ago. You might have other issues, you might have a call missing or an extra call, but if you have some experience and you know what you're looking for, you can quite often just stare at the code and say, hey, this looks wrong, kind of all of a sudden understand what's going wrong. Other than that, debugging is a very associative process. I mean, if things get very, very, very messy, you can start doing a more standardized process, writing down everything you know, writing various hypotheses about what could possibly go wrong, and then starting to discuss how you can collect that extra data you need to validate or remove those hypotheses, potentially by adding tons of prints. That's how it usually works. But early on in the process, I found that associative thinking leads to faster results in most of the cases. And that's another reason to look at the code, because once you kind of get a look of the code, get a sense of the lay of the land, then you're better positioned to look at additional data, whether it's logs or metrics you've discussed or the bug report itself or anything else, to kind of see things in context rather than just trying to piece everything together from scratch.
Great. All right. The next part of the show, I think, is everyone's favorite, unpopular opinions. Hope you guys came with one.
Unpopular opinions.
I actually think you should probably leave.
Unpopular opinions.
right, who wants to go first?
I'll go. My unpopular opinion is about OpenTelemetry. I know OpenTelemetry is being touted as the one to vanquish them all, but I find it to be over presumptuous in many cases, way too complex, and hardly that much of a benefit over structured logging. In most cases, obviously there are exceptions. There are super fancy, super complex cases where you have 2,000 microservices like Uber had until they figure out it was the wrong approach, in which case you desperately need distributed tracing and OpenTelemetry, and good for you for inventing that. The rest of us mere mortals are better off not overcomplicating our systems and not overcomplicating our observability solutions. Simple is always better in engineering in general, in software engineering in particular. Logs are awesome. They've been with us since the dawn of computer engineering. Metrics are pretty sweet as well. If you want to get extra fancy, structured logs are truly great, and they can be very simple. They can have literally a couple of lines of configuration on any piece of log, of the logger itself, and you configure it. And on top of that, OpenTelemetry in Go is a lot of boilerplate, a lot of configuration. You have to set up all the middlewares yourself. So don't hold high hopes for that. You're picking a very complex, a very expensive solution that's going to have, in most cases, it's going to have less value. In some rare cases, you might never meet. It can have more value than the more traditional approaches.
I definitely resonate with it being a lot of boilerplate and overly complicated. We made a move to that and abandoned it because it's a lot.
Sounds like the unpopular opinion is popular.
Yeah, I also agree. I never worked much with OpenTelemetry, but with other solutions that basically are observability and metrics. And yeah, you can go a very long way with just well-structured logs. Even almost have a distributed trace just based on logs. And super simple, because you can just, parse them or put them on Elasticsearch, something like that. And then you can just see the logs together, aggregate them. And yeah, you can go a long, long, long way without overcomplicating. So my unpopular opinion, I still believe that the testing package from the standard library is the best testing framework that you need, like the best out there. It's very simple. It's very powerful now, especially now that fuzzing is built into the language and everything. And because it doesn't introduce new concepts, so basically you still have to do your if statement. If that thing happened, then I call a method on my T object, right? Or my B for benchmarks and things like that. It makes the developer, the engineer, writing the code, think more about what they're doing and probably also craft better testing failure messages. So instead of just say like A is different than B, it's like, no, hey, I was trying to do that and that failed because of that. You can still fall in the pitfall of just say A is not B, but I think it's less. I think there's some libraries that have like a gigantic public API for testing that just gets hard to use. And if some very small nuances here and there, I've seen a few examples of that just like misplaced, like would be the error message, if the actual error that was being compared, then luckily the test was not very wrong, but that happens. And if the testing package, like that's just not going to happen, right? You can only basically print a message saying like, okay, the test, you can fail the test, and then you can write messages explaining why. And well, of course, like building language is very different than building other kind of applications. But as far as I know, in Go, like to write Go, they only use the testing packages. So it's powerful enough to write Go. So it should also fit, say, most, if not all use cases. And you can always write your helper function if you need specific things. And the t.helper, it's also a great helper.
Ooh, I'm worried that one's going to be popular as well.
Yeah. I brought an unpopular opinion as well.
Oh, wow. Okay.
I think that as a manager, be it a team lead or a product manager or whatever, making a round of messages on your tracking system, like be it Jira, Trello, whatever. What's the status here? What's the status here? What's the status here? And then your developers arrive the next day to like 10 messages that all look the same. What's the status here? Is one of the worst things you can do.
Definitely.
No, it's supposed to be unpopular. Don't say that.
The Elon Musk way is much, much better. Tell everybody they're fired next week if they don't deliver what you've came up with overnight.
Now that's an unpopular opinion.
No, all those status messages never fail to give me anxiety. It's like, wait, was I supposed to get all of these done?
Even if, yes, there's better ways of doing that than 10 messages of what's the status here.
Yeah, definitely.
Maybe you have an agreement that you should update at the end of every day, every week, every other day. I don't know. If you don't have such an agreement, you should set that up. If the team is not happy with this agreement, you need to find something else. But just around, like opening your inbox to 10 of those messages is just like, I'm going to close the computer. Bye.
Yeah, I agree.
If you expect people to spend the time to write down the answers, you should spend the time at least to write down questions that prove you know what each task is about and be more focused about what you're asking rather than generic, what's your status? Because I might as well answer, it's progressing.
Perfect. Oh my God. Adopting.
I think I would even say like some of those status update messages are like the bug logs. They just say like, yeah, it's moving, it's happening, but most of the time it's not what you need to see, not what you need to hear.
Yeah.
True. It is like info level messages.
Yeah, I would even say the bug. What you need is the error level. Like, hey, that's delayed because of that. Or like, hey, I had a problem and blocked it here. So task X, Y, or Z is not moving or even moving backwards.
I think we're onto something here.
Yeah.
We also have a lot of questions that we wanted to talk about and lots of topics we wanted to talk about, and looks like there's no other choice but to have a follow-up episode. And I want to say thank you both for joining. I hope you will join to our next episode on debugging, and I want to wish everybody a good rest of your day wherever you are, whatever your time zone is. Bye everyone.
All right, that is the show for this week. Thanks for hanging with us. If this is your first time listening, subscribe to the pod at gotime.fm. And if you're a longtime Go Timer, do us a solid by sharing the show with your friends. Help us help more people with weekly Go-related goodness. Thanks once again to Fastly and Fly.io for partnering with us. Check out what they're up to at fastly.com and at Fly.io. And of course, thank you to our beat freak in residence, Breakmaster Cylinder. Our beats are banging because BMC bangs out dope beats. That's how it works. Next time on Go Time, John Calhoun returns, and he's teaming up with Johnny Borsico to discuss gRPC and protocol buffers with guest Akshay Shah. Stay tuned for that. We'll be dropping it into your podcast app next week.